All right, everyone. So now we are going to talk about how we look about all this data on maps. And now here is my cat Nub. Now you finally get to meet her. Oh, here she is in all her fat glory. But sweet girl, gotta do some work. Okay, so we've talked about all this data now, and let's figure out how we look at all this data on maps. So the first thing that we like to do is look at what we call the station model. So this tells us so much information about what is happening in our atmosphere. And it may seem small, but it also may seem like a lot. And there is a lot going on here. And don't worry, in our labs, we will totally dissect this bit by bit by bit by bit by bit. And you'll be masters at this, have no fear. But what we're looking at here, just to give us a little rundown, we have our of our numbers over here on the left-hand side. We can determine our temperature and our dew point temperature. For this particular example, they're in degrees Celsius. For our purposes, when we look at station model maps, it will all be in degrees Fahrenheit. So have no fear there. One big thing to note is that the dew point temperature will never, ever, ever be above the actual temperature. So when we get to actual moisture and talking about that, that will hopefully make a little bit more sense, but just know that the dew point temperature will never, ever, ever be above the actual temperature. And then the little symbol in here will tell us if there's any significant weather going on. And significant weather could be anything from rain, snow, thunderstorms, anything like that. Again, in labs, we will go in depth about what all those symbols mean, but just so you know, anything that is in between those two numbers will be our significant weather. And then this fun little guy here, this tells us three main things. One, cloud cover. So basically how filled in this circle is will tell us how many clouds are in the sky. And then this little thing here we call a wind barb. And this tells us wind speed and direction, meaning where the wind is coming from. So in this particular example, the wind is coming from the northeast. So again, if you ever need to, draw a little compass to remind ourselves northeast, south, and west, no shame in that. I do that all the time. And then this number here on the right side tells us our atmospheric pressure. And we'll go through this again later, but we have to decode that. It's not the exact pressure. Like, for example, this is not 987 millibars. We have to do some things to it to tell us our actual pressure. But again, we'll get into that later. But this is just our little introduction to what this is. So this information can be plotted all over the country from these automated weather stations, and it can look something like this. To us right now, it may look a little bit messy, but that's okay. But from some standpoints, we can actually get a decent idea of what's happening with the winds, directions. If we look further into the numbers, then we can see temperatures and all that kind of stuff. But again, we'll totally dissect this information later. So this is an example from your book. This is what it would look like in real world examples. So I pulled this from August 31st, 2001. So it was from last year, but we can see what this kind of looks like. There's also some color coding here. The red numbers mean temperature, the green numbers mean dew point. It kind of makes it easy for us to figure out which one's which is quite nice. But these are not the only variables that we can look at on maps, or we can actually visualize it in different ways. And we can see these things and we can dissect them with contour lines. And these lines of constant value are called contours. So maybe some of us are super into makeup, similar sort of idea with contouring and making our face look so much different than what it looks like. But we do that in meteorology in terms of pressure. So we call those isobars. With temperature, we call those isotherms. With wind, we call those isotachs. So perhaps by now you've been able to discern that the part of the word that's iso means equal. So when we see those on maps, we can look at isotherms and temperature maps. When those lines are super, super close together, that tells us that there's a really sharp temperature gradient called fronts. So when I say gradient, you can think of something like walking up a hill, and that's something we're rather familiar with here in San Francisco. A sharp gradient means a really, really intense hill. A smooth gradient means something rather flat. So for example, here, if we're looking at the state of Missouri, for example, we can see there's a heck of a lot of lines going on here, which means there's a pretty sharp gradient. Again, this is an example from your book, how we may look at temperature maps in other aspects that are maybe a little bit more tangible to us, or something like this. And it's a different color coding. What's really nice about this particular image from Windy is they color code it in a way that the freezing line is that really beautiful blue color. So why is this important? Because we can then identify what we call fronts on maps. So think of, for a moment, when I think of the word temperature and I say the word front, think about what kind of temperature contrast we could look for here. Think about it for a moment, maybe even pause the video and give yourself a second to think about it. Did you give yourself a second? Or are you just continuing on? That's totally fine. So the fronts that we're going to be dealing with are cold fronts and warm fronts. So we have cold air advancing into warmer air, or we have warmer air advancing into cooler air. And what's kind of nice is we can put all this information on multiple maps, or put all this information, we can put all this information on the same map and give us a total idea of what's going on. So we can also look at something called pressure, or, we talked about pressure earlier, but we can also give a similar sort of identification similar to this, going back to something like this with pressure. So with pressure, we like to look at and visualize regions of low pressure and regions of high pressure. And oftentimes, those regions will be indicated with an L for low pressure, indicated with the color red, or high pressure, indicated with the letter H, but in blue. So the reason for this is so that we can point out regions of disturbed or undisturbed weather. And the general rule of thumb is that we look for regions of low pressure, because that tends to be where the more disturbed weather happens to be. So again, this is an example from your book. Perhaps some examples that we look at in kind of the real world or from the National Weather Service would look similar to something like this. So it's a little bit busy. This is generated by a computer. So there's a lot of H's, there's a lot of L's. It's kind of a little bit more of this idea of a computer generated thing. So it just kind of puts things where a computer says there's high pressure or low pressure. But usually with human-generated maps, they make it a little bit less busy. But here's an example of something that we may look at in class. So what's nice, or what's interesting, I suppose I should say, with pressure maps, you can kind of think of them like topography maps. And even with contours just in general, a way you can kind of think about it, again, with the contours a little bit closer together would indicate a tighter gradient or a steeper hill. And when they're further away, that means a lower gradient, so a less steep of a hill. So when I say a topography map and a topographer example, when I'm talking about high pressure regions, you can think about it like kind of hiking into a bowl. So remember when we talk about pressure, it's like how much atmosphere is on top of your head. So if you're standing in the middle is H, then there's more atmosphere on top of your head for whatever reason in that moment. But if we were to be in this region of low pressure, you can try to imagine it as if you're at the top of a mountain where there's less atmosphere on top of your head. And this is simply a way to kind of somewhat visualize it. It's not a perfect example, but the reason why I like to show this one is because, we have the Peru-Chilean Trench down here. So there would be a region of high pressure because you have more atmosphere on top of your head. Pretend that there's not an ocean there. It's just, just kind of a mountain or whatever. And then if you were on top of the Andes Mountains, there would be lower pressure on top of your head. You can also think about it with like the gradients and stuff, like the gradient here going from the bottom of the high pressure up the mountainside. There's a really steep gradient there, right? If you were to hike that, that would be moderately uncomfortable. Like you'd be kind of dying by the time you get to the top of this region. But like right here, right at the coastline, it's a little bit more steady, right? And perhaps another way to think about that, if this example doesn't work very well for you, if we were to like look at a higher level in the atmosphere instead of at the surface, this would be kind of what we see. So over here on the left-hand side, on our x-axis, we're basically going from west to east. And on our y-axis, we're looking at altitude. So when we're looking at this H here, the level there, the topographical level is much higher than on the right side where the topographical level is seemingly lower. So, and these blue lines here are their lines of constant pressure. So again, it's kind of a funky concept, but we'll have a little bit more practice with that later. And what's really interesting is we can put all of these concepts together. Like I said, we can put pressure and temperature and fronts all on one map and can look something like this. So here we have pressure, temperature, and fronts. Gives us what we call a synoptic view, so an overall large-scale view of the weather patterns over the United States. So we have our H, we have our L, the black contour lines here, the isobars show us that kind of bullseye sort of pattern. The gray contours are showing us the temperature or the isotherms, and then overlaid on top of that are our actual front drawings. So our cold front is here and our warm front is here. So that can be a way that we think of things at the surface. And in my next video, I'll show you how we look at things further up the food chain, or further upstairs, as I like to say, in the upper atmosphere. So thanks so much for watching how we look at things at the surface.